SAS is typically seen as competing with other popular languages such as R and Python for analytics and data mining applications. While there is certainly a large element of truth in that, the fact is that SAS embraces the reality that programmers want to work in the environment with which they are most comfortable and familiar, and existing investments in any one language should not preclude using any of the others in your analytics solution. In support of that, SAS provides a number of ways to interface with other languages to develop hybrid solutions. R, Python, and other languages can be called from your SAS code, as outlined in a recent SAS GitHub repository. This video demonstrates the ability to invoke SAS's high-performance analytics from Python, R, Java, or other languages through web service calls. By registering your SAS code as a stored process and parameterizing the key elements that you want to expose or extract, it is automatically made available to call from any client that can make a standard RESTful web service call. Here we see the SAS Management Console, where we can create a new stored process from the SAS code that we want to make available as a web service. In this case, we will create a service that trains a random forest classification model on a specified data set, exposing various tuning parameters as options that can be passed in. With our stored process in place, we will now use an IPython notebook to demonstrate the ability to call SAS from Python, in this case to train a random forest model on a dataset of 160,000 customer transactions to classify them as potential repeat customers. Our SAS environment is configured to run on a Hadoop cluster with 142 nodes, so the SAS HP Forest proc will allow for significant performance improvement by distributing the training of the decision trees across all nodes, in addition to utilizing all of the CPUs on each node. First, we're making a call to a web service that simply returns details about the data set, which is distributed in HDFS. Next, I will make a call to train the random forest model using SAS's high-performance analytics in Hadoop. You can see the call I'm making here to invoke our SAS Random Forest Training Web Service, constructing a standard header for the call and providing input parameters through XML. In this case, training 250 trees using 20 candidate variables for splitting each node. We can bring up our grid monitor here and select our job to see how it is utilizing the nodes on the Hadoop cluster. You can see the activity on these nodes indicated in green, and when the job completes, they go away. Let's take a look at our results. In this case, the web service returns the HTML output generated from the SAS code so that all of the results are nicely presented in tables and graphs and we don't have to write any code in Python to post-process them. But if we want to, we can retrieve the raw results in XML or JSON format to work with directly in our Python application. Since the ultimate goal of training models is to score them on new data for predictions, we've defined another web service to score a specified data set on this model we just trained, in this case 150,000 new customer transactions from which we want to predict repeat shoppers. So I've passed in the model and the new data set as parameters to the Random Forest Score web service, and we can see in our grid monitor the scoring is distributed across all of the nodes. Again, the results are returned, already post-processed as tables and graphs showing the frequency of predicted repeat customers. As I mentioned, with our SAS analytics exposed as web services, we can access them from any client that can make a call through HTTP to the appropriate URL. We can write custom web applications such as this solar farm energy forecast, we can write Java clients such as this one that solves a specified optimization problem formulation, and we can even make this same call to train our random forest model from R, here using RStudio.